Hello students, how are you all? Welcome to online classes. In the last video we have discussed about last session we have completed isotopes, isobars, atomic number, mass number, few simple problems we have discussed. And in this session I am going to discuss about nature of light. Now, nature of light. So the nature of light is explained by two theories. There is light having dual nature. The dual nature of light is explained by two theories. One is wave theory, another one is corpuscular theory of light. The first one is wave theory of light, another one is corpuscular theory of light. Okay. So wave theory means it indicates wave nature. Wave theory explains about wave nature of light. Corpuscular theory explains about particle nature of light. It means light having dual nature. One is wave nature, another one is particle nature. Wave nature is explained by wave theory of light. Particle nature explained by corpuscular theory of light. So now we discuss wave nature. Wave means first of all wave nature we will discuss. Wave theory of light. It is indicated wave nature of light. Okay. So wave, one is a wave, another one is particle nature. Wave means it is continuous. Particle means discontinuous. It is discontinuous, right? So now first of all, what is wave? Wave is nothing but a mode of transfer of energy without transfer of energy. So wave means transfer of energy only but not matter. So that mode is named as wave simply. Wave is continuous especially. Now, in the wave theory, the first scientist given is, wave theory was given by Huygens. It was given by Huygens. According to Huygens, the light transmitted to space in the form of wave. So he said that light or any radiant energy which will be transmitted in the form of wave through space. This is what he gave. According to Huygens, light move through, what is that? Light or any radiant energy It means any substance can emit energy, radiant energy, move through space through space in the form of wave. So this is the nature given by who's that? Huygens. Afterwards, Maxwell came. So according to Maxwell, any charged particles moves under acceleration. Acceleration means a change in velocity. Moves under acceleration, then generates alternately electric field as well as magnetic field. This electric field and magnetic field transmitted means moving in the form of wave. So this alternate electrical and magnetic field is called electromagnetic wave, also named as electromagnetic radiation. Now, according to Maxwell, light or charged particle oscillates. Oscillation means moves under acceleration, then alternate electric field and magnetic field produced. The produced electrical field and magnetic field transmitted in the form of wave called electromagnetic wave. Or electromagnetic radiation. Here you have to observe one thing. So electric field as well as magnetic field will be formed in alternative way. So that is in this way I am drawing here. Yes. It is a propagation of light direction. So one is like this I have taken. One is electrical field, another one is magnetic field. How magnetic field will be generated and formed. So just observe this. Like this. So one is, this is, I am showing like this. This is electric field or magnetic field. Electric field, it is magnetic field. Both are in opposite direction, perpendicular to each other. And this is the direction of propagation of light. It is the direction of propagation of light. It means light is traveled in that direction. To that direction also these two rays are or fields are perpendicular to each other. And these electrical and magnetic fields are perpendicular to each other again. So now electrical and magnetic fields are perpendicular to each other. It means opposite to each other. Next, these two fields are again perpendicular to the propagation of light direction. So those are the points we find. The produced electric field and magnetic field perpendicular to each other and perpendicular to the direction of propagation of light, the direction of propagation of light. Electrical and magnetic fields are perpendicular as well, and these are propagation also so these are perpendicular to the propagation of light also. Next, these rays are traveled in absence of any medium. No medium is required to pass these rays, especially. So, no medium. These rays even can pass through vacuum also. So, no medium is required to pass. No medium is required to pass this EMR. Even can pass through vacuum also. Even can pass through vacuum also. Next, the intensity of light. Intensity of light is directly proportional to the maximum electric field strength into maximum magnetic field strength. It is indicated as I is directly proportional to electric field into magnetic field. Like that we can consider. So this is the wave nature. Before going to the electromagnetic spectrum, we should know characteristics of waves. Yes, first characteristics of wave. It is also called properties of wave. So in this we should study about wavelength, frequency, wave number, next time period, velocity, amplitude. These are the terms we should study, and their units, formulas are important. Now to study first one, wavelength. First characteristic is wavelength. Yes, first one, wavelength. It is indicated by letter lambda. This is the wave. So, right. This is called crest. This is called trough. So, the distance between the two adjacent points, or the distance between the two successive points, called wavelength. It means the distance between the two successive crests or two successive troughs, called wavelength. The distance between two successive points, called wavelength. It means, so this is crest now. Between two crests taken as wavelength, between two troughs taken as wavelength. Okay, and another one also you can continue here. So this point and this point, it is also considered as wavelength. Any two successive points, adjacent points, that distance is taken as a wavelength. SI unit of wavelength equal to meters. You can use other units also, centimeters, picometers, nanometers, angstrom units, whatever the unit that is. Now, 1 angstrom unit equal to 10 to the power of minus 8 centimeters, 10 to the power of minus 10 centimeters. 1 nanometer equal to 10 to the power of minus 7 centimeters, minus 9 meters. 1 picometer equal to 10 to the power of minus 10 centimeters, 10 to the power of minus 12 meters. Unit conversion, you know. So it is very, very important. You have to remember to solve problems on this scale. Next, 1 picometer equal to 10 to the power of minus 10 centimeters, 10 to the power of minus 8 into 10 to the power of minus 2 centimeters. Shall I write like this? Minus 10 will be taken as minus 8 into minus 2. Minus 8 centimeters equal to 1 angstrom. 10 to the power of minus 8 centimeter equal to 1 angstrom into 10 to the power of minus 2, that is equal to picometer. 1 angstrom unit equal to 1 picometer by 10 to the power of minus 2. It will be taken as 100 picometers. Unit conversion is very, very important. Better you convert the nanometers into angstrom units into picometers, picometers into angstrom units, nanometers. So in this way you need to convert this. Formula B, generally nu equal to C by lambda, where lambda wavelength equal to C by nu. Wavelength formula is C by nu, frequency, and it is velocity of light. Okay. Next, after this, second term is frequency. Frequency of wave. Frequency indicated by nu, letter nu. Frequency means number of waves passing through a given point per 1 second called frequency. Number of waves passing through given point, certain point, given point in 1 second. In 1 second called frequency. In 1 second called frequency. Units are seconds, otherwise hertz, otherwise cycles per second. Right? Formula is nu equal to C by lambda. Means velocity of light by wavelength of light. So this is about frequency. Next, wave number. Second one, third one, wave number indicated by nu bar. It is reciprocal to that of wavelength. Number of waves in unit distance called wave number. Otherwise, number of wavelength per unit distance called wave number. It is reciprocal. It means inversely proportional to that of, reciprocal to that of. What is that? Wavelength. Reciprocal to that of. Definition. The number of waves per unit length called wave number. Otherwise, the number of wavelengths, both are correct, per unit length called wave number. Wave number is inversely proportional to wavelength. Nu bar is equal to 1 by lambda. This is the formula. Nu bar equal to lambda units are meters, SI units. Then units are meter inverse, SI units. SI units are meter inverse. So you can take another units also, centimeter inverse. This is wavelength. Next term is, after this, the next term is amplitude. Amplitude, this is fourth term. Amplitude. Right. Amplitude is nothing but, as I told you, this is the wave. The height of the crest or the depth of the trough. The height of the crest or the depth of the trough called amplitude. The height of crest or depth of trough called amplitude. Generally, amplitude is a measure of intensity, nothing but brightness of your light. Amplitude is a measure of intensity or brightness of light. Brightness of light, that indicates which one that is amplitude. Units are meters. Units, SI units are meters, centimeters, picometers. Also you can consider units. Next, velocity. Velocity of light, nothing but the wave. It is fifth term. Velocity, it means the speed. The distance travelled by a wave in 1 second called velocity. The distance travelled by wave in 1 second. The distance covered by the wave in 1 second called velocity. All types of electromagnetic radiations and their velocity seem similar to that of velocity of light. All electromagnetic radiations speed or velocity same as that of velocity of light. Velocity of light. Velocity of light is indicated as c 3 into 10 to the power of 8 meter per second. Otherwise 3 into 10 to the power of 10 centimeter per second. If it converts into centimeters, 10 to the power of 10 centimeters. Units are, I wrote already, units meter per second, otherwise centimeter per second. So these are the units. Next, time period is, it means time required for completion of one cycle. Sixth time period. It is indicated as time required to complete one cycle called time period. Right? It is inversely proportional to frequency. It is reciprocal to that of frequency. Reciprocal to that of frequency. Time period equal to 1 minus Because just small t actually. Okay. So 1 by nu means 1 by second inverse of this. Obviously you will get seconds. Units are time it is. That's why seconds. Clear? So these are all fundamental terms to solve problems. Now before going to problems, I'll give you electromagnetic spectrum. After that, we'll discuss one of the problems. All the electromagnetic radiations, it means UV rays, IR rays, X rays, gamma rays, microwave, radio wave, these are all electromagnetic radiations. These all electromagnetic radiations are arranged in increasing order of wavelength and decreasing order of frequency. That order is called as electromagnetic spectrum. Clear? Definition for electromagnetic spectrum. Right. Electromagnetic spectrum. Electromagnetic spectrum. The arrangement of all electromagnetic radiations in increasing order of their wavelength in increasing order of their wavelengths and decreasing order of their frequencies called electromagnetic spectrum. These all frequencies these all radiations having similar velocity with light velocity. It means the velocity of light is equal to the all electromagnetic radiations velocity. So I will draw the spectrum. It is already given to remember. So just I will draw. Okay students, I arranged all the electromagnetic radiations in this order. So this is wavelength, downside frequency is there actually, I didn't mention frequency. Wavelength lower, gradually positive, it means increases. Increase in wavelength order or decrease in frequency order, because wavelength and frequency are inversely proportional. Now, cosmic rays, gamma rays, X rays, in this range UV rays, in this range visible region it is VIBGYOR, violet, indigo, blue, green, orange, red colors are there. Yeah. Next, IR, infrared rays, microwave rays, as well as radio and TV rays. It is not required, but ranges are important. Just remember the ranges. So based on the given formulas, nu equal to c by lambda. So on that formula, a few problems, one sample problem we will discuss. Yes. Question. The wavelength of radiation is 2000 angstrom units. Calculate frequency, wave number, time period, frequency, wave number and time period. Now, solution for this question. They gave wavelength that is equal to 2000 angstrom units. So you can take it as 2 into 10 to the power of 3 angstrom units. So you can take it as 2 into 10 to the power of 3. For angstrom unit equal to 10 to the power of minus 8 centimeters. Otherwise minus 10 meters. You can consider it. So if you consider SI units now, minus 10 meters. Finally it is 2 into 10 to the power of 7 meters. 10 to the power of 3 and 10 to the power of minus 10 converted into 10 to the power of 7 meters. 7 or minus 7 meters. Now, after this, first question is frequency. Frequency equal to nu equal to c by lambda, where c equal to velocity of light already 3 into 10 to the power of 8 meter per second, and frequency wavelength equal to 2 into 10 to the power of minus 7. Substitute c 3 into 10 to the power of 8 meter per second by 2 into 10 to the power of minus 7 meters. Meters to meter cancel, per second left, it means second inverse. So you will get 1.5, it is into 10 to the power of c by lambda is, yes, minus 7 shifted to numerator, then you get 8 into 10 to the power of 7, 1.5 into 10 to the power of 15 second inverse, or hertz or cycles per second. This is right. Next, second question is wave number. Wave number is inversely proportional to wave. Wavelength already given 2 into 10 to the power of minus. Nu bar equal 1 by 2 into 10 to the power of minus 7 meters. 1 by 2 means 0.5 into 10 to the power of minus 7. It will be taken as 5 into 10 to the power of minus 1. Finally, you can take it as 10 to the power of minus 8. Meter shifted to numerator, then you get meter inverse. Next question is, third question is, what is given the time period? T equal to 1 by frequency. Already frequency we have calculated. This is, that is equal to 1 by 1.5 into 10 to the power of 15 second inverse. So answer you will get is second inverse converted into which one, that is seconds. Yes, it is 0.66 into 10 to the power of minus 15 seconds. 6.66 into 10 to the power of minus 1. So it will be 10 to the power of minus 16 seconds. Such problems are possible on this data. We'll continue in our next video, that is particle nature. Till now I have discussed wave nature, Maxwell corpuscular theory, followed by electromagnetic radiation, electromagnetic spectrum, and wave properties. In the next video, I'll discuss particle nature of light.